Use the remainder theorem to find f of -4. Well, we're pretty good at this. That means we're using synthetic division. Add down and multiply, add down and multiply, add down and multiply, add down. That's the remainder. So the remainder theorem says that f of -4 equals that number. Next one, factor this expression, okay? And that would be hard to factor, except for they give me this information that -7 is a 0. So if I know that -7 is a 0, then I can break this problem down. Add down and multiply, add down and multiply. 7 times 14 is 98. Add down and multiply, add down, okay, 0. But I knew it was going to be a 0 because they told me it was going to be a 0, right? That just tells me that this is a 0. I already knew that. Or this is a factor. I know x plus 7 is a factor, but what I've done, more importantly, is I've broken the problem down. It was an x to the third polynomial, but I factored it, or I knocked off a power of x, and so I broke it down into an x squared. 3x squared minus 14x plus 8. I think the best move here is to factor this expression. If you don't know how to factor it, then you could just start trying stuff and trying to do synthetic division again. But I honestly think it's better to factor here. I want to factor this. I'm looking for numbers that multiply to 8. You'll notice they don't add up to 14, but that's because one of the numbers is getting multiplied by 3, specifically this one over here. So you have to think about it. How can I take these numbers and multiply one of them by 3, and then they'll add up to 14? And I can see it pretty quickly. 4 times 3 is 12, plus 2 is 14. All right. Notice I haven't even thought about the negatives yet. I always wait till the end. Okay. I know these numbers have to multiply to a positive, but in order for there to be a negative in the problem, both of those numbers must be negative. Okay, so I know it's -4 times 3 is -12, plus -2 is -14. That's going to work out. What you need to do, though, is make sure you put the -4 in the position that's getting multiplied by the 3. The -2 goes right there. I'm trying to factor, remember. So we'd have 3x minus 2 and x minus 4. And, of course, don't forget the x plus 7 that we had at the beginning. Those would be your factors. Yes?
So could you technically synthetic division through the whole entire thing?
Yes, you could. But the problem if you did synthetic division is you wouldn't know what number to plug in or to try. Okay? So we have a method for doing that. And, you know, it has to do with, where was it? It has to do with this. When we figured out the possible rational zeros, once you figure out what's possible, you could try synthetic with those numbers. So you might do a 56 and 3 and try those numbers, or short of that, you could really just try anything you wanted, I suppose. I don't really like doing that because it gets frustrating when something doesn't work and I don't get a 0 and I have to try something else and try something else. I think the fastest way is if you're good at factoring. But if you're not good at factoring, then yeah, you're going to need to do that probably. Just try synthetic until you find something that hits. Okay, good idea. This was just a division problem. Remember, when we divide, they're not giving you the 0 value. You have to come up with the 0 value yourself. So you have to say, well, let's use x equals 2. We're going to do synthetic, but we're going to use the 0 of 2. Be sure to check for any missing terms. If you've got a missing term, you've got to put a 0 in there. I don't see one here, though. Add down and multiply. Add down and multiply. Add down and multiply. Add down and multiply. Add down. We're dividing. So if you're dividing, we are knocking off one of those powers of x. Okay, so that first term, if I knock off a power of x, is going to be x to the third. And then it just counts down from there. Minus 4x squared plus 2x minus 1. And the last number is always your remainder. So you're going to write that as a numerator of fraction, 21 over, remember we're dividing by x minus 2. Next one, factor completely. Okay, so this looks back like your question. This one's harder than the last one because the last one they gave you a number to try first. We broke it down, we could factor. This one, they don't really give you any way to start. Okay, so what I'm going to do is synthetic division, and I'm just going to try numbers. Now, I don't want to just try any old number. I've got a way to narrow it down and find intelligent numbers to try. Okay, intelligent numbers to try are going to be, factors of 15 and factors of 3, basically. Okay, so I'm going to list out anything that could possibly work. And that's where I take my red numbers divided by my blue numbers. 1 over 1 and 1 over 3. And 3 over 1 and 3 over 3. And 5 over 1 and 5 over 3 and 15 over 1. Oops. And 15 over 3. Okay. So technically you'd clean that up and say plus or minus 1, plus or minus 1/3, plus or minus 3. 3 over 3 is 1, so I've already got it. Plus or minus 5, plus or minus 5/3, plus or minus 15. 15/3 is 5, so I've already got it. So those are the numbers that are possible. Those are the numbers that might work in my synthetic division. They're definitely not all going to work. If I'm looking at this polynomial, I would expect at most 3 of them to work. So it's kind of a guessing game. You have to try to figure out what you think is going to work. Try something. I will usually stay away from the fractions, but it's really just kind of a lucky guess type of thing. I'm going to start with 1. Add down and multiply, add down and multiply. And I can tell right now it's not going to work. So really, as soon as you can see it's not going to work, you can jump ship and try something else. Okay? Unless I messed up there. So I try -1. Add down and multiply, add down and multiply. I can tell right now it's not going to work. A lot of the times you can tell pretty quickly if something's not going to work. So 3. Add down and multiply, add down and multiply, add down, yuck. I don't even know what that is, but I know it's not going to make 0, so I'm going to just abandon ship there. Add down and multiply, add down. This isn't looking so good. 48. Ooh, that looks good. 5, -15, and 0. Okay, great. Finally found one. Okay, it took me a little bit, but I found one that worked. Okay, if I'm trying to factor, I know this x plus 3 must be one of my factors. Okay, x plus 3 must be one of my factors. But also what I've done here is I've broken it down. It was x to the 3rd, but now I know that I've got this equation as well. If you want to continue doing synthetic division, be my guest. Keep trying numbers if you want to, but I hate it. Okay, it really bugs me when I can't find the right number. I'm pretty good at factoring, so that's what I would do. 3x squared minus 16x plus 5. I know it's going to factor into 3x and x. I need 2 numbers to multiply to 5. There's not that many possibilities. It's got to be 1 and 5. So your job is to make 16 using a 3. Okay, and it doesn't take very long to figure out that you could just multiply this by 3 right there. That's going to be 15 plus 1. That's going to be 16. Okay, now what about a negative? If this problem has a negative in it, but this multiplies to positive 5, that tells me that both of those numbers are negative. Okay, it must be that way in order to make it work. So all I have to do is put the -5 over there in the position that gets multiplied by the 3 in the FOIL process. So I put a -1 there. So I've got all my factors. I'm just going to write my answer. I've got an x plus 3 and a 3x minus 1 and an x minus 5. Now I'm factored. It doesn't really matter what order you put those factors in. There's 3 of them. Put them in any order. Sometimes people would say you had to put the 3 first, but I guess it doesn't matter.